Hi, welcome back to my channel. Today's presentation is about correlation and association in statistical analysis. And this presentation is a part of a playlist on observational research. I hope you watched previous videos. Now, I need to remind you that this presentation is a part of quantitative research methods on the family of observational research. And the objective of today's presentation is to learn to detect relationships between variables through correlation analysis and to learn about correlation tests like the Spearman correlation, the Pearson correlation, and the Contingency Coefficient test. Now, earlier we discussed that we are falling under the category of inferential or parametric statistics, and inferential statistics or inferential analysis is used to measure the reliability of conclusions about a sample of the population. Also, we talked earlier about the different types of inferential statistics. Today we are going to focus on the correlation under the Pearson, the Spearman, and the Contingency Coefficient tests. I'm going to talk today about a general introduction, then I will explain the three famous tests before some takeaway messages. Now let's start with the introduction. Well, what is the logic behind statistics and why do you conduct statistics? Statistics is conducted for 6 main objectives, either to, number 1, describe and characterize, number 2, to detect variance, number 3 is to compare and test hypotheses, and number 4 is to establish association and correlation, and number 5 is to predict and model, and number 6 is to prove causality. In our case today, we are focusing on establishing association and correlation. As you know, association has a definition, and association means that the pattern of data in one variable seems to occur in a certain manner that is related to the pattern of data in one or several other variables, and not every association is a correlation. This is very important takeaway. However, when we define the correlation, correlation is a measure of how strongly two variables are interrelated. The correlation ranges between 0 and 1, and a statistical correlation might be devoid of meaning despite the association. So this is also important to take into account. Now, what is a correlation in fact? Actually, a correlation test informs us about the strengths between two variables or more. So we will see how strong there is a relation between those variables. And this means that between two dependent variables, two independent variables and dependent variables, we can conduct this relation and start to see what is this relation between them. A correlation coefficient, Pearson, is used, or the Spearman's or the contingency, to range between -1 to +1, where values closer to -1 imply a negative correlation, and the +1 implies a positive correlation, and values closer to 0 imply no correlation. So this is how it goes with the interpretation of the results, and always you will fall between the 0, 1 and the +1 regarding your analysis. And let me give you here an example. This is a correlation analysis that simply is plotting on the x-axis the chocolate consumption in kilogram per year per capita in different countries, and on the y-axis we can see the Nobel laureates per 10 million of population. In this sense, we can start to say, okay, there is a correlation between the people, countries like Switzerland. It has a very high number of quantity of chocolate consumption per year, per kilogram, but in the same time, it has a very high number of Nobel Prize laureate. This correlation here is there, but it could be an association. It doesn't mean that this is a causation. We cannot say that people who are eating more chocolate, they will have more Nobel Prize, for example. So here, this is an example of the correlation and the, let's say, rough interpretation of mathematical analysis without adding sense to the information, without contextualization. So this is very important to take into account. Now, how can we conduct correlation analysis, and what is a correlation analysis? Well, correlation analysis is simply a way to describe the relationship that links two variables together, and the official definition of correlation is two variables are correlated if a unique change in one variable leads to a change in the other variable. So they're moving together. Correlation can be either, like we said, positive or negative. In this case, we can have here a positive correlation where the two variables move in the same direction. We increase the x, the y increases, for example. while we can have a negative correlation the other way around. The two variables move in the opposite direction. We can have also something very important to know and learn about, which is the correlation coefficient, the beta, which is used to measure the degree of the association of the two variables. And also, as part of our correlation analysis, we need to understand that the general linear model is a framework for comparing how several variables affect different continuous variables, and then we can have the equation of the dependent variable equal the function of the independent variable and the unknown parameter plus the error terms. Based on this equation, we can establish this correlation and describe it mathematically. So the regression coefficient beta signifies the amount y changes for a unit increase in x. In this way, it represents the degree of which the line slopes upwards or downwards. So this could be also done mathematically. Now, the significance level of the statistical test is the probability that the test could have occurred by chance. So therefore, we have to come up with a calculation on the significance level. If the level is quite low, that is meaning that the probability of occurring by chance is quite small, meaning that if it's lower than 0.05, if it's higher than 0.05, meaning that the test chance is occurrence is high. This means that we having most probably a result by chance. A p-value is a measure of the probability that an observed difference could have occurred just by random chance, and the p-value must be noted. Give the p-values as exact values whenever possible. Only giving the values of your correlation without communicating your p-value means that your study is not complete and is not accurate. Now, another important thing to take into account that we can establish correlations if we discover that we have a positive or a negative correlation and we have a high p-value. We can start now go further into detail, and we can run a series of tests that will measure the linear relationship between two continuous variables, like the Spearman correlation, the Pearson correlation, or the contingency coefficient. For sure, there's other nonlinear tests, multivariate tests, but those are the most famous tests so far. Let's start with the first one, the Pearson correlation. What is the Pearson correlation? Well, the Pearson correlation coefficient is a correlation coefficient that measures linear correlation between two sets of data. It is the ratio between the covariance of two variables and the product of their standard deviation. It is a normalized measurement of the covariance such that the result always has a value between -1 and +1. Now let's move to the second test, which is the Spearman correlation. The Spearman correlation, the Spearman rank correlation coefficient, is a non-parametric measure of rank correlation, which based on the statistical dependence between the ranking of two variables, and it assesses how well the relationship between two variables can be described using a monotonic function, and the Spearman correlation of +1 or -1 occurs when each of the variables is a perfect monotone function of the other. Now let's move to the last test of today, which is the contingency coefficients. The contingency coefficients can be used to estimate the extent of the relationship between two variables or show the strengths of a relationship, and it's another way for calculating the correlationship for our samples. This is the end of today's presentation. Some takeaway messages before leaving you. Correlation can be calculated in different ways, either as a simple correlation between two variables or with a correction being made for such influences, if you remember the figure E. A correlation test informs us about the strengths between two variables, between the two dependent variables, two independent variables, a dependent and independent variables as options, and a correlation coefficient like Pearson or like Spearman or like the contingency range always between -1 and +1, where values closer to -1 imply a negative correlation, +1 will imply a positive correlation, and values closer to 0 imply no correlation. And finally, correlation does not imply causation, and you need to go for further tests if you want to prove the causation. Well, that's it of today's presentation. Thank you very much for your attention. Don't forget there are following videos coming in the same line of this playlist. Today's presentation was about correlation and association in statistical analysis. Thank you very much.